All right, well, the one last thing before we wrap this up, which is that we now also need to automate the turning off of the displays. And by now you're probably thinking, hey, I bet that Q-SYS has a deep integration into the displays. And you're correct. We also, in the same way that we had a wealth of information of HDMI on the input side, we have a wealth of information about the output side, i.e. interfacing with the displays. And so if you double click on one of the display components, you will be able to see there's all kinds of information. And one of the ones that we are particularly interested in is this one right here called sleep mode. When this particular LED is activated, it means the televisions have gone to sleep. When might this happen? This might happen if you've disconnected all of the cables and you've walked away for the day, and that little blue input screen is just left on the screen. There's nothing worse than walking through the office at the end of the day and all of the conference rooms are still on. We can do better. We can make everything turn off.
Well, you can actually control when that sleep state initializes right there. So you can choose what type of behavior and how long it has to occur should trigger that sleep state to be sent to the TV.
The thing that we're going to tie to, though, is this little LED. And you might be saying to yourself, oh, I bet I know how to do this. I'm probably just going to go over, I'm going to select and expose a pin and wire some stuff in, because that's kind of how we did it in the fundamentals class. And the answer is yes, that is absolutely a good and right way to do it.
Sweet, that's what I'm going to do.
That is not how I'm going to do it.
Son of a, every time, Jeff, every time.
We're going to do it a different way. My family's favorite meal is spaghetti, but when I open a DSP file and I see wires going everywhere, it just sometimes makes me want to just like take a little break and pause them, walk away before I come back and dive in.
It makes me want to take that person and just hold them and fix whatever went wrong in their life.
Yeah. And sometimes I'm the one who needs that hug because I'm having to untangle the spaghetti mess. And I know, I can hear you already saying, but you've got flags. It's true, you do have flags. But one of my favorite methods of control doesn't need wires or flags or control pins at all. I like to use the methodology called named components, because it enables me to be able to talk directly to a component in my design and interact with it from my script. One of the things you should be thinking about when you think about your script is that they are individual, isolated universes. They only know about themselves until, using name components, you tell them that there is another component in the universe that they can interact with. And once you do that, once you give it the name and tell it the secret code name, then your script is able to interact with that other component and can have an event handler that talks into the component to make the component do things, can even watch the component and set event handlers for that particular component. Now, those event handlers live inside of that script. They don't live inside of the component. They are watching that component. So what we are going to do is not use the control pins. Like you could, but we're not. I'm going to teach you a new way of interfacing script to component. One of the things that's really important about using named components is you need to know the name of the component. There's a couple different ways to figure this out. When I click on left display, we can see that there are two relevant pieces of information that shows up. One is that on the component itself, it says left display. But then, like a little hat, there is this EMU display 1 that shows up on the screen. If I look over in the Properties tab, I can see here is its name, here is its label, i.e. its legend, but also down here, here is its code name. Now, by default, when you bring in a component, it gets a generic code name, and the script access is set to none. The script access thing is a matter of security by default. But the idea is that we need to give our components good code names. Now, because you are inheriting a file that has an emulator in it that is using name components so that you don't see wires going everywhere, we already have code names established for many of the components in this design. These two displays already have code names. You know that because they are prefixed with EMU. EMU display 1. And the other one is called EMU display 2. And as we move forward, you'll see that we are going to interface with some other components that also have that EMU prefix on them.
I was pretty sure that meant these were used exclusively by emus.
Yeah, or it was emusing.
Yeah.
Yeah. You've got to give it a code name. You got to set the script access. Our components already have a code name, and their script access is already set to all. For those of you keeping score, there are a couple of other options. There is external, there is script, there is none. Basically, script means that this component will be accessible to other scripts inside of Q-SYS. External means that it will be available to external third-party controllers, but not available internally, whereas all means fair game. We're going to leave ours set to all. It's going to be fine. The other thing that we're going to need to know is the name of the control that we want to interface with. It's kind of like knowing what is the name of the control pin. Really, there's one good way of figuring that out. And this is my way of figuring that out. If I go into runtime and I hover over the control I'm interested in, I will see that there is a friendly description. HDMI AV input sleep state. That's the friendly description of that control. But I need the actual control name. The way that I find the actual control name is by going to Tools and going to View Component Controls Info. When I do that, a little pop-up window shows up. And if I then click on our component, you can see that our little helper here has populated with 42,000 different control names. That's because there are a bunch of controls on this single component. What that really means is there's a lot of control power at your fingertips in the Q-SYS environment. There are lots of little buttons and knobs and things that you can work with. As you look through the list, you'll see that there is a certain organization to it. You will see down here that there is this one, right? Because it said HDMI AV input sleep state. HDMI AV input sleep state. This is it. I read the friendly description. I found the friendly description. I found the control name. The control name is HDMI.sleep.led. And then helpfully, it tells me that it is a Boolean. That's good to know. Okay, so we've learned two things so far. We've learned that components can have code names, and then that those components have controls. Here's how to figure out what they are. So we've seen that when we build scripts and that we build controls, they're always on our list of controls, etc. Similarly, when we are looking at a Q-SYS component, we can see its list of controls by doing this. So we want to tie to this component's name and to this control's name within it. So with all of that as a preface, let's write the code because it's going to go really fast. So here we go. Let's dig in. I'm going to close that because I'm going to remember what it's called. And the first thing that I need to do is I need to establish that connection from my script to those components. And I'm going to do that by creating a variable name. My variable name is going to be very descriptive. I'm going to call it named comp display 1 is equal to the output of the function, right? Component, right? We have a library called component. It's one of the Q-SYS extensions to Lua. And within the component library is a function called new. What the new function does is it's creating that tunnel, that pathway, that connection from my script to that component. So component.new, and it's going to take an argument. The argument is the code name as a string. Our code name was emu display 1. We're going to do the same thing for the second display. So display 2 and display 2. Lines 54 and 55 have created that connection between our script and those components. What we want to do from here is we want to have our script look into those components and set event handlers for when those lights go on and off. That's what we want to do. So let's do it. So we need to say the name of the component, which is right there, line 54. Named component, named comp display 1. What on it? We want a particular control. So here's how we reference that particular control. We're going to use square brackets, and then we're going to put inside of it a string. The string is that name of the control, which was HDMI.sleep.led. And on that control, we want to access its event handler. And just like you would expect, the event handler is going to equal a function. We're going to pass in CTL. And because we opened it, we're going to close it. And the logic is going to be almost the same as the logic from those pins. If CTL.boolean, then what are we going to do? We are going to call func power. And what do we want to have happen when that light turns on? The light turning on means that the televisions have gone to sleep, which means we want to turn off the televisions. We're going to pass in false. We also are going to run func debugger. We're going to say that it was display 1. And what is it going to do? It turned them off. So very similarly, write the other event handler. Named comp display number 2, and then in func debugger, display number 2, hit save. And now we can test our script out. Navigate to displays, connect HDMI 1, that turned the televisions on. We also have this in-room action called displays go to sleep, where we can pretend that the televisions went to sleep. And when you do that, look at that, it turned the televisions off. And we are getting very helpful feedback information in our debugger window. Our debugger is really helping us know that things are working the way they're supposed to work. That actually concludes this particular exercise. We have added a power button. We have dynamically changed its legend to be very descriptive. We have remembered the power of having an initialization function. We have learned how that Q-SYS has deep hardware integration with HDMI so that we can know when laptops get connected. We also have learned that we have deep hardware integration on the output side as well. And lastly, we have seen the power of named components. And I can promise you, we're going to use this move even more as we proceed.
Now, for my friends who are hanging on from the intermediate class, we're glad you're still here. You may be wondering to yourself, hey, a lot of the things we've done so far are similar to the things we did in Block Controller, but it was easier in Block Controller. I didn't need to memorize the names of these weird brackets and the names of the things down the line. Why wouldn't I keep doing it in Block Controller? We mentioned earlier, right, the importance of each of these tools have a function. And what we've done so far with Lua is very similar to what we did in Block Controller, but we're getting deep, right, Jeff? What we're going to do soon with Lua will go well beyond what we ever could have done in Block Controller. You may remember at the end of that class, we said, hey, we're scraping the edge here where now you need to be able to do full Lua. That's where we're going soon. So
We are.
So if you're getting frustrated by all the syntax of having to type things exactly right and it not always being there to autofill it for you, and thinking, why can't I do this easier? What we have done, you could. But we're going farther.
We are. We are wading out. It's going to get deeper.
Yeah.
And hopefully you are beginning to develop comfort with what we're doing. So with that, take a little break. We'll see you in a few.